going on, guys? So today we're going to be doing a quick mid-unit review over what we've covered in the past 2 weeks. So we're going to jump straight into subatomic particles. So we talked about what atoms are made up of, and we know that atoms are made up of 3 different subatomic particles. Those are going to be your protons, your neutrons, and your electrons. Now each one of those has very specific characteristics. So we're going to go through them. Your protons carry 1 atomic mass unit, that is how much weight they carry. Protons have a positive charge, and then protons are found in the nucleus of an atom. Again, that's going to be the center of an atom. Next up, you have your neutrons. Your neutrons carry 1 atomic mass unit as well. Neutrons have a neutral or no charge, and neutrons are also found in the nucleus along with protons. Finally, you have electrons. Electrons carry 0 AMUs. They have no mass whatsoever. They have a tiny amount. We don't count it. We round it down to 0. Electrons have a negative charge or carry a negative charge, and electrons are going to be found outside of the nucleus in a thing called the electron cloud. Now, if they ever ask you for the charge of a nucleus, inside the nucleus you have protons and neutrons. So the only actual charge you have in there is positive. So inside the nucleus you'll always have a positive charge. If they ask you for the charge in the electron cloud holds electrons. And the only thing you'll find in there are electrons, which are negative. So it'll always be a negative charge. Now, once you're able to figure out the different types of subatomic particles that make up atoms, we now need to look at the different elements that these atoms make up. So we look at a periodic table. So in a periodic table, there's a whole lot of information. You'll see a whole lot of elements on there. Again, you'll see them all in these squares, and they have different numbers on them. So if you look at the top one up here, you have aluminum here. At the very top, you have the atomic number. You have the atomic symbol for aluminum, Al, and then you have the atomic mass. Now, the atomic mass is made up of protons and neutrons, because protons and neutrons, again, carry the mass for an atom. The atomic number, though, will give you 2 different things. It'll give you the number of protons and the number of electrons. So we already have 2 of the 3 subatomic particles that we need to do an atomic model. All we need to figure out now is just the number of neutrons, but we already have the number of protons. This is protons plus neutrons. All we need to do is subtract this number from this number. So we subtract the atomic number from the atomic mass. That'll give you the number of neutrons, and we now have all 3 subatomic particles. So, for example, aluminum has 13 protons, 13 electrons, and then 13 minus 27 is going to be 14, so 14 neutrons. Again, you're almost ready to draw an atomic model or a Bohr model. And the reason it's called a Bohr model is because it was invented by Niels Bohr quite a bit ago. So, again, you have your protons, neutrons, and electrons. Now we need to figure out how many shells, how many circles are around it in the electron cloud to figure out how many electrons we put in each electron cloud, because we can't just throw them in there. So, we move back onto the periodic table, and again, you'll see more information on there. If you look on your far left-hand side, there are numbers 1 through 7 going down. Starting with 1 all the way down to 7, again, those are read in rows, so horizontally. So you'll have period 1, period 2, 3, 4, so on all the way down to 7. Every single element in that row will have the same number of shells or the same number of orbitals. You also find something else on here, and that's the number that you find at the top, and those range from 1 to 18. Now, if you see here, there is a wide range that we leave unnumbered, and the reason for that is because those are transistor metals. We don't talk about this in 8th grade. They're weird. We don't like them right now, so we leave them to the side. So we have group 1, 2, 13, 14, 15, 16, 17, and 18. Those are the 18 groups that we're going to be talking about. Now, what those give you is a number of valence electrons. And valence electrons are just the electrons that we find in the outer shell. It's the electrons that we find in the last shell of a Bohr model or of an atomic model. And those tell us quite a bit of information, but we'll get to that in just a second. Let's move back. So again, if you're in group 1, you're going to have 1 valence electron. Group 2, you're going to have 2 valence electrons. Group 13, this is where it gets tricky, has 3 valence electrons. Group 14 has 4 valence electrons. 15 has 5, 16 has 6, 17 has 7, and then 18 is going to have 8 valence electrons. But there is an exception on there. and that's going to be helium. Helium only has 2 electrons in total. There's no way that it can have 8 valence electrons. Sorry about that. Again, just use common sense when thinking about helium. It has 2 electrons. How can it have 8 valence electrons when it only carries 2 electrons in total? So it only has 2 valence electrons, not 8 like the rest of the group. The reason it's there is because it behaves the same as the rest of them. These are called noble gases for a reason. They are very, very stable. And we'll talk about that in just a second. Now, once again, those group numbers are going to tell you the number of valence electrons. So again, valence electrons are electrons found in the outer shell. And they tell you quite a bit of different things. They tell you the reactivity of that element. Is that element stable? Is that element reactive? How reactive is it? How stable is it? Again, valence electrons can give you that. Valence electrons can also tell you which elements behave the same. So if they're found in the same group, if they're found in the same column, because groups are read in columns, up and down, vertically, they have similar characteristics. So let's say that you're working with lithium. Lithium is number 3 on the periodic table. It's in group 1. But you ran out of lithium and you need to use something that's similar. You can use any other element on that group because it will behave the same. You probably will not want to use hydrogen because hydrogen is a gas and the rest of them are metals, but they all behave the same. So you can use sodium, you can use potassium, rubidium, any of those would work kind of the same to lithium because again, similar properties. Now if we finally get everything together, we have a Bohr model down here. I don't know if you guys can see it very well because it is kind of far away and it's very small. In the center you have your nucleus. In the nucleus you put your protons and your neutrons. This is a Bohr model of boron. Boron has 5 protons, 5 electrons, and then it has a mass of 11. So 5 minus 11 is going to give you 6. So it has 6 neutrons, 5 protons, and then again 5 electrons. Boron is found in period 2. So it's going to have 2 shells, and it's found in group 13, which tells me it has 3 valence electrons. So again, I like to start out from the outside with the valence electrons, so I put the 3 valence electrons on the second shell. That leaves me with 2 electrons left. That's awesome because I can only put 2 electrons in the first shell anyway, and that lets me fill everything in. And again, if you're having problems remembering that, again, the first shell is going to be the one closest to the nucleus. The second shell is obviously the second one. One thing to keep in mind, guys, whenever you are determining the identity of an atom, count the protons. The protons will always tell you what element you're looking at all times. And in the event that you cannot tell because either the protons haven't got a positive charge on them or it's a black and white picture and you can't tell the difference in color, you can use electrons as long as you have a neutral atom. And as far as you know in 8th grade, that is the case. If anybody has any questions, please feel free to ask, guys. Good luck tomorrow on your test. Have a good day. See y'all tomorrow.